Hello everyone, we're going to do example 11.1.2 in your class notes, or Himmelblau example 6.6, which is a recycle problem where a reaction takes place. So you're given this reaction where benzene reacts with hydrogen to form cyclohexane, and they give you the process flow diagram here. They also give you that there's 20% excess hydrogen in the fresh feed. They give you the composition of the recycle, and as you can see, the recycle does not have any of the cyclohexane in it. So all the cyclohexane that is produced in the reactor goes to the product stream P. They also give you that the reactor has a 20% conversion, but that the overall conversion is 95%. And we get that 95% conversion by using this recycle. And then the question that they have is, what is the ratio of R over F? So that's what we need to calculate. We need to find out what is R and what is F. So the first step is to draw a diagram. Now they've already given you a diagram, but I redrew it so that I can fill in the information as I do my calculations. So already I've filled in that there is 20% conversion in the reactor. And we also know that there is a 95% conversion overall. Now that I've filled in what I know, the next step is to choose a basis. Now the easiest place to choose a basis is at the fresh feed. Now you can choose the fresh feed total to be the basis, or you can choose one of the components. So I'm going to choose benzene as my basis. And the reason I'm doing this is that I have a 20% excess hydrogen. So if I compare benzene to hydrogen, I can use that 20% excess to calculate how much hydrogen I actually feed. What I'm also going to do is label these other streams. Okay, so now that I have a basis, I know how much benzene comes in. So I know that I also have a 20% excess of hydrogen. So if I look at my chemical reaction, for every 1 kilomole of benzene, I need 3 kilomoles of hydrogen. So I need 3 times 100 kilomoles hydrogen. But what I feed is 20% excess, so I have 20% more than that 300. So I have 360 kilomole hydrogen in F. The other way you could do it is also, you could say 1.2 times 300. So here I have 100 kilomoles and 360 kilomoles. Now I can do an overall balance because I know what the overall conversion is. So if I draw my boundary across the whole reaction, I know that this is 95% conversion. So I look at F and I look at stream P. So if my overall conversion is 95%, we will look at the C6H6 for that, because that is the limiting reactant. So 95% reacted. So what is left is 100 minus that 95 kilomoles that reacted is 5 kilomoles C6H6 out in stream P. Now I also know that if 95 kilomoles C6H6 reacted, stoichiometrically 3 times as much hydrogen needed to react. Because for every 1 mole of C6H6 reacting, 3 moles H2 will react. So we end up with 285 kilomoles H2 reacted. And this is then the inlet, which was 360 minus what reacted. And we are left with 75 kilomoles H2 out. Then the third and final component is the cyclohexane that we formed. So check the stoichiometry of your reaction. The benzene to cyclohexane is a 1-to-1 ratio. So every 1 mole of benzene reacting forms 1 mole of cyclohexane. So if I reacted 95 kilomoles of C6H6, I know that the same amount, so 95 kilomoles of cyclohexane formed. And that comes out in product stream. So here I have 95, 5, and 75. So now I know the total of product stream P. I know what's going on in F, but I don't yet know what is going on in R, and that is what I need to answer my question of R over F. So now we need to use the next piece of information that we were given, which is this 20% conversion inside the reactor, and we will now use mass balances. So we can now move from the left to the right. This stream that I labeled A is a mixture of R and F. So I can say A is R plus F. Then I don't have enough information because I don't know R and I don't know A. I only know F. So I need a component balance to create another equation because I only have one equation and 2 unknowns. So I'm going to do a C6H6 or benzene balance over the reactor. So I know that the benzene in A is the benzene in F plus the benzene in R. Now, this is unknown and this is also unknown, but I can rewrite it in terms of F and R. So I know I fed 100 kilomoles of benzene in F, and I also know the composition of stream R. I know I have 22.74% benzene in R. Now I still have R, A, and the benzene in A as unknowns, so I still need more equations. Now, I know the conversion, and that is the next thing that I will be using. I have a 20% conversion in the reactor. So if I have 20% conversion, it means 20% of the benzene was consumed, which means that 80% of the benzene that we fed to the reactor, which was the benzene in A, comes out in stream B, because only 20% of that benzene fed was actually converted. So the benzene in B is 80% of the benzene in A. Now we are at the separator. We know that the benzene that came out of the reactor in B is the sum of the benzene in P and the benzene in R, because it just separates them. So C6H6B is the benzene in the product stream plus the benzene in the recycle stream. And this I still know because I did my overall balance. It was 5 kilomoles of C6H6. That is the product stream. And I've already defined the C6H6 in the recycle as 0.2274 times R. So I can equate these two equations now. So that is my one equation. But now I still have two unknowns, so I need to go back to the previous equations. What is C6H6A? I defined it here in terms of R as well. So I can replace that C6H6A with this 100 plus 0.2274R. And then I can solve for R. And there we have the answer for R. So now I can actually find out what is R over F, since I've calculated R. And F is 100 plus 360 because it is the benzene and hydrogen. And then that is 3.58.